Welcome to FarmBeats for Students, precision agriculture experiences for school and home. In this video, I'm going to walk you through the FarmBeats Student Kit Build Instructions document, so have that somewhere nearby to reference. The Grove Smart Agriculture Kit consists of the Raspberry Pi 4, environmental sensors, a relay, and a dual button component, and it performs 4 main functions. It collects sensor data, it transmits the data to Excel, it manages the data logger file, and it manages the agent you set up. To get started, take all the components out of the box and unpackage them. Hang on to all the pieces, including one of the plastic bags, the twist ties, and maybe a couple rubber bands, because you might want to use them later. Compare your components with the kit contents list from your build instructions to make sure you have everything you'll need. Next, we'll walk through all the steps to build the kit, assemble the sensors, and power up the Raspberry Pi. Don't hook up your Pi to power until later in the setup process. Finally, remember that the activities and the kit assembly requires adult supervision, and just like you do with any engineering, design, or field project, you'll want to wear appropriate eye protection. All right, let's get started. The first step in the kit assembly is attaching the Grove Pi hat. You'll need the Pi and the Grove Pi hat, the screws and standoffs, and this teeny tiny screwdriver. When you unpackaged the kit, you saw that the parts came packaged up in sturdy bags, Ziploc bags, and came held together with rubber bands and twist ties. You don't want to throw all of these things away, because you can use them to store pieces or to secure the wires more neatly later. To assemble the Pi and the Pi hat, flip the Pi over. Insert one of the screws into one of the corner holes on the Raspberry Pi. While you hold the screw with one finger, twist one of the standoffs onto the screw until it fits snugly, and then repeat for the other 3 screws and standoffs. Your Raspberry Pi should now look like this. It's ready to attach the Grove base hat. We'll be putting screws in the corners of the Pi hat to lock into these standoffs. Next, we want to carefully align the pins on the Raspberry Pi with the socket on the Grove base hat and press it firmly together. Slide the pins and make sure they connect snugly. When you're done, they should slide all the way to the bottom and it'll look something like this. Now take one of the screws and insert it through the top of the Pi and into the standoff. Use your screwdriver to tighten it. And then you'll repeat for the other 3 screws. Congratulations! Your Grove base hat is now firmly attached to the Raspberry Pi and ready to start attaching sensors. The environmental and soil sensors are used to capture data from your garden. The sensors included in the FarmBeats for Students kit are connected to the Raspberry Pi using the Grove base hat, which provides solderless connections. The computer code on the Raspberry Pi that reads your sensors will look for them at specific locations on the Grove base hat. The sensors are plug and play and can be connected or removed while the Raspberry Pi is running. You can use the photo and reference table in the build instructions as a guide when you're connecting the sensors to the base hat. The numbered slots on your hat may not be in exactly the same location. First, here's the temperature and humidity sensor. This sensor will measure the air temperature and relative humidity in the garden. The kit came with several connector wires. They're really flexible, so once you have the kit together, you can adjust them to work in your space. You can keep the rubber bands to secure them later on. Insert one of your connector wires firmly into the sensor, and then you're going to insert it into the spot marked D16 on the Raspberry Pi. There we go, first sensor connected. Next is the relay. A relay is a device that uses an electromagnet to control a switch that's connected to a circuit. This circuit is decoupled from the relay circuit, allowing the relay to control a larger current, for example, a water pump. We're using the LED light on the relay during some of our activities. Plug a connector into the relay, and then you'll want to connect it to slot D22 on the Pi. Next, the dual button sensor is a pair of binary switches. We're using the blue and red caps for our setup. Start by attaching the blue button cap so it's on the button closest to the Grove connector. It'll take a little bit of force to snap the cap in place. Next, attach the red cap to the other button. In our activities, we'll use the blue button to take a snapshot of our sensor data, and we'll use the red button to turn off the Pi. You'll use a connector, and you're going to plug the dual button sensor into spot D18. The next sensor is the soil temperature sensor. This sensor has a long wire with a waterproof capsule, making it ideal for immersion in the soil. Because the wire is long, you'll want to use a twist tie, rubber band, or whatever works with your setup to keep the length manageable. The one-wire temperature sensor goes in slot D5 on your hat. The next sensor is the capacitive soil moisture sensor. It works by detecting changes in electrical capacitance in the soil as moisture levels change. This is a qualitative measurement and will give a relative moisture level. It goes in slot A0, and on my Pi that's hidden under the wire from the fan, so you might have to look around a little bit on yours too. There it is. We're getting close now. The next sensor is the sunlight sensor. This sensor can measure visible light, ultraviolet, or infrared. We'll be measuring visible light in lumens. It can go in any slot labeled 12C. You might have 2 or 3 marked this way, and any one of them is fine. Okay, that's all our sensors. You can see we have a bunch of wires now, so you'll want to find a way to keep things under control. The next step is to attach the USB TTL serial cable to the pins on the Raspberry Pi. You can see the cable has 4 wires, white, black, red, and green. We'll be connecting black, white, and green and leaving red unconnected. We're connecting the pins to the outside edge. Be very careful to leave a space of 2 pins at the end of the row, and then you'll connect black, white, and green in that order. Your connector should slide right onto the pin. Make sure to leave those 2 spaces at the end. All right, look at that. Everything's all assembled. We've left our red pin clear, and we're ready to move on and add the SD card. The next thing that you're going to want to do is look in your kit for your SD card adapter. It looks like this. Open it up by pulling off the cap, and then take the micro SD card out. The spot for the SD card is on the back of the Pi, right here. Place your micro SD card into this slot so that the printed side is visible. Push the card firmly into the spot. The SD card included in your kit will already be ready to use. If there's any issues, you can see the appendix in the instructions on how to flash the card. The Pi is powered by a USB-C power supply. Whenever you remove or insert the card, you want to make sure that the Pi is not plugged in. Next, we're going to take the USB end of the USB TTL cable and plug it into our computer. With this connection in place, you can get the sensor data from your Raspberry Pi into Excel. You can also send data from Excel to the Pi. We'll be configuring an agent and sending other information to the Pi this way. Okay, we're finally ready to power it up. Plug the USB-C power supply into the Raspberry Pi and plug it into a power source. As soon as the Raspberry Pi is powered on, it'll begin to boot up and the red and green lights will flash on and off a few times. The first time the Pi boots up, it'll take about 1.5 minutes, and then after that the boot time will take probably about 30 seconds. When the Pi is powered on, you might even hear your fan start up, and that's great. Here's our finished product. Our Pi is powered up and running, all the sensors are connected, and some of the wires are pretty long. But since they're flexible, you can bend them and secure them however works best in your setup. Great job! You're ready to start collecting data. Remember that the Pi and most of its components are not waterproof, so you won't want to leave it outside unprotected. Thanks for watching!